go to the materials, and we'll go down to data classes. All right, so let's start by talking about one-dimensional classes. I know it's we're starting to get a little jargony, but when we talked about this at the very beginning of the class, we were meaning just things like, a number or a vector of numbers, just a couple of numbers strung together using the combine function. So we've already talked about character and numeric classes or data types. So we can use the class function for this. Let me shrink this down a little bit and clean some of this up. Clean my environment. All right. So we talked about how we can use the class function. We, maybe would make a vector that has character data in it, this tree and cloud on the slide. And then if we ask what the class of this vector is, it is character. It's basically text data versus a number vector. Could be numbers like that. And when we ask what the class of that vector is, should give us numeric. Okay, so we've already talked about these a little bit. And especially, taking a look at our data, for example, the CES or the ER data, the county in this example is going to be character data. And something like a rate or number of visits or the confidence level or confidence interval would be numeric. We already talked about this a little bit, but what happens when things get a little messy? So character is going to predominate if there are mixed classes. So if we have something that looks like this, it's going to be treated as a character because we can easily put quotes around these numbers, but how would we make tree into a number? It's not going to work. So this would end up being a character vector. And then likewise, if we have something like this, where we have quotes around all our numbers, even though they could be numeric, the quotes are going to take precedence. So anytime you have some like weird text or formatting, you have maybe, some typos where you have text with your numbers, then you're going to have character be the predominant class. All right, so we didn't talk too much about another type or class of data, and that is the logical type. And it's only going to have two possible elements, true or false. And if we were to ask what the class of this was, right, something that looks like trues and falses, it's going to tell us that that's logical. So we could have my vect3, we're just making a whole bunch, could be true, false, false. And notice that they're kind of in this different color, right? So that's going to look a little different than if I did a capital and then lowercase or all lowercase. We do have to have them all uppercase. And so what's the class of this one? It is logical. Okay, so some things about logicals that we might want to think about are that logicals are not in quotes. So these do not have quotation marks. If I did put those in there and then asked, it would say, oh, that's a character. I saw one single quotation mark and I'm gonna just make sure that character predominates. So no quotation marks. And you can also, if you're feeling really, you don't want too many keystrokes, you can do just the capital letter and that will be sufficient. I do like to spell it out just because it is more readable that way. So if we think back to our examples where we had this as one of our arguments, I personally think that that is a little bit harder to interpret, right? Somebody might be looking at that and be like, well, what does T mean? What object is T? But when you spell out true, I think that's a little easier to understand. Okay, so that is our logical class of data. All right, so why is class important? I know we've been harping on this a little bit, but the class of the data is going to tell R how to process the data. So for example, it's going to determine whether you can do summary statistics, so whether you can take the mean, or whether you could sort something alphabetically, right? So it's going to tell everything that you apply to it. It's going to tell those functions how to work. Okay. And so in case there are any times where you need to maybe make a correction and you need to coerce between classes, you can do that. So you can use functions that follow a pattern of as dot and then the class name. So let's say you've got something you want to make it numeric. You could say as dot numeric of whatever that object is. You could say as dot character of whatever that object is, or as dot logical. All right, so let's see how this works. So sometimes it works really great. So we could have something like as dot character. It's pretty easy to turn things into a character, right? You just put some quotes on it and call it a day. So like as dot character of the number 2 is now going to have quotes on it. We could also do as dot numeric of 1, and it will remove the quotes. And we could do as dot logical as long as we had trues and falses. That should be pretty easy to interpret for R to interpret, something like that. It's like, okay, I know what you mean there. However, you can also spell it a little bit different and it still understands what you mean. And then finally, the cool thing is R interprets ones and zeros as trues and falses too. So there's like a little binary link there. So 0 would be equivalent to false and 1 would be equivalent to true. Okay, so sometimes it works really well. However, when R is not able to figure out what you mean, when it's ambiguous, R will return NA. So it means not available. It's a missing value. And when it's part of a coercing function, so as dot numeric would be coercion, it says NA is introduced by coercion. You're trying to make R do something with the data that it just can't. It says, I give up. So taking something like, we'll do 2, 4, and 6. We're not going to not going to write it out. It's saying, I don't know what to do with that. It's going to give it an NA value. All right. So let's say we're dealing with some data. And so what is one reason we might want to convert data to numeric? So we can take the mean, so our data looks better, or so our data is correct. Why would we want to turn it to numeric? Seeing some A's. Yeah. Okay. So I like, I didn't intend for C to be a correct answer, but yeah. So you could even think of it as being a little bit more correct. The values are not different. So, and it's not going to check whether, you observed the data correctly, but yeah, we want it in the format that would give us what we want. So I agree with you a little bit there, but yeah, so we could take the mean, right? So yeah, because if we've got a vector that looks like this, right? And we want to take the mean, I can't do it, right? Because it's character data. But if we put a as numeric in there and fixed it, we could take the mean. All right, good. I think we're on the right track. All right. So there are 2 major number subclasses or type. And the discrepancy here really isn't super important. You just may see different terminology. But double is a numeric type that has decimals, and integer doesn't. So double stands for double precision numeric. So it just means it's a little bit more precise than an integer. Okay. So again, double is basically equivalent to numeric. It can have fractional values and can have any amount of places after decimal. And so, like I said, for most purposes, the difference between these doesn't really matter too much. It doesn't change whether you can take a mean or a sum or anything like that. But if you're interested in kind of looking at the distinction here, you're welcome to explore that a bit. But you may see double thrown around as kind of an equivalent term to numeric. You also may have noticed that when we are looking at data in the console, so for example, we looked at that ER data set that I deleted from my environment. So let me run that one more time. That we have different numbers of decimal places depending on where we look, right? So I have a lot of decimals here, but I've kind of looked like I've done some rounding. So that just has to do with the way that the table is displayed in RStudio. And so you can play around with the formatting here if you are curious about it. All right. So we learned about a little bit more about numeric types and we learned about logicals, but there's also a very special class that we think is pretty important to know. It's going to help us keep things organized down the road. And that is a factor, which is a special character class of data. And it's special because the elements or the, distinct values have predefined groups or levels. And so this is where, this is a qualitative or categorical variable where order is often important. So some examples here, I know that maybe you're like, well, when would the order be important? In a categorical variable, one is not necessarily like greater value than the other. And so we can think of a couple examples here. So the colors of the rainbow, we typically want them in a specific order. Not always, but we might. Instead of alphabetical order, we might want them in rainbow order. We might want breakfast, lunch, and dinner in that order because they happen at specific times of the day. We might want different terms for like developmental stages. So, a baby to a toddler child to an adult. Typically, that's chronological as well. We might rank responses on a survey. So somewhere from strongly agree all the way up to strongly disagree, that we may want those categories in order. And finally, we might rank experience levels from beginner all the way to expert. So we'll learn more about this later, but these are character vectors with defined levels. All right. And so here's a quick overview of that. I think this is a nice table to refer back to. Okay. So special data classes, let's talk about this a little bit. And I think that these are going to be probably our most popular classes when working, especially with dates and times. Often we'll have data sets that have dates in them or times in them, and we don't necessarily want it to just look like text. We want to recognize that things are ordered in time. And so date is a class representing a calendar date, and POSIX CT class is going to not only represent the calendar date, but will also have hours, minutes, and seconds. And so we can convert data from a character type, from text, to one of these to be able to manipulate date and time. And so knowing this, there's an additional package. We're not always working with date information, but if you are, there is a really helpful package called Lubridate. And that is going to be really helpful for working with date and POSIX CT objects or columns of data. All right. So let's talk about how we would create a date class object using Lubridate. And so let's make sure I have that package loaded up. We'll make sure I have installed it if I haven't already, and load it with library. And so I might be creating a variable that looks a little bit something like this. So it could be today's date, so 2024, and it is 10, it is 03. Okay, so what class is X right now? It's going to be character, right? There's not a lot of information going on there. It just got quotation marks around it. However, maybe I want R to interpret this as a date. And so what I could do is take the YMD function. So it's going to parse dates with year, month, and date components. And so, okay, I've got year, month, and date up here. Let's do YMD of X. So it looks very similar, but let's go ahead and assign that to an object and then take a look at the class of that object. It's of date class. And if I take a peek over here in my environment, the original X it just shows the character type with quotation marks. However, I'm looking down here and it says, oh, it's giving me, a date, and it's, thinking that it has some kind of relevance in terms of like time zone and things like that. And again, the function YMD is taking a look at the data itself. It's saying, I'm going to parse this as year, month, and day. All right. So given that these two look very similar, right? They almost look identical, really, unless we look at the class information. Why would we bother doing that? Well, because dates can be helpful for, determining time difference or understanding like the time span between two dates, which we can't really do if we have character information. You can also find the maximum and minimum dates, and that's not necessarily going to be the case alphabetically, right? So if we look at a date that looks like this, so September 30th, and we look at a date that is something like this, and let's say maybe we didn't have the 0 in there or something like that, this date might be listed first alphabetically, right? Because 1 would come before 9, and it's just going to look at each character along the way. Okay, so dates can be really useful if you have to do math or find durations or find max and min. All right. And so the Lubridate package has a bunch of these functions, and the function is going to match the format of the data. And so if I have something that is formatted like this, where it's month, day, year, then I'm going to want to use the Y function. And notice how it formats it kind of a consistent pattern. It's always going to put the year, the month, the day, and then separate it with dashes. So no matter what I give it, it will parse it in that way. Same thing, I can also provide it with spelled out month names. That's also fine. All right. So we may be wondering, we're like really harping on classes and talking a lot about vectors here. And you may be wondering, what does that have to do with my data sets? My ultimate goal is to do some data wrangling and do some data science, right? So I want us to think of when we have a data set, such as this ER data set, I want us to think about each column being a vector. Okay, so each column has values, but it also has a class associated with it. So county is character data. Rate is double, it's numeric data. And same with all of these columns here. Year, we might want to actually interpret as a date, but for now, it is considering this to be a number. I think that's probably okay because we're not looking at months or days. So let's talk about how we might explore this in a data set. And so let's take a look at a SARS-CoV-2 wastewater data set. So this was data set on measuring viral load in wastewater between 2022 and 2024. And the way that they kind of sampled this was looking at a first sampling date and then a final sampling date and kind of looking at how concentrations changed within that window. So the start and the end date were very important to them. And so let's read some data in, and I'm going to copy that here and make sure I do the URL here instead. Okay, so creating this object, we'll read it in and az.org/data. All right. And then we'll select a few columns for easy viewing. So if we take a look at the SARS data set, it's got quite a lot of columns, but let's just select a few of them to play around and see kind of how this class conversion can work. So we're going to use our select function to subset those columns. I'm going to select town name and we'll select start date or date start. All right. So a little bit simpler here. Okay. So when we look at this data set in the console, we can see that date start is of character class, not date. Yeah, so town name is character and date start is character, but that may not be how I want it to be processed, right? Because again, this 6 may come after October, for example, right? So October starts with the number 1 and June starts with the number 6. So they may not be ordered correctly. All right, so let's play around with trying to do conversion in this data set and clean things up. So let's use the mutate function to help us modify the column. So we'll do SARS wastewater, and we can use the pipe to send that into mutate. And we're going to say, all right, well, let's do date start, but fixed. We want to fix it to the date type. All right. And then taking a look down here, I want to use a lubridate function to parse this. So I'm going to say, well, what format is it in right now? It's in month, day, year. So we should use DY. And we should do that on the date start column. So let's see if that does what we want. All right. So just taking a quick look, I can see that this new column has the date class and that it's also done some formatting for us. Remember, I mentioned it always kind of does this year, month, date with dashes format. So the data itself hasn't changed. It's just actually processed and parsed it correctly. All right. So very, very helpful for us to know, about lubridate, but also we may come into a case where we need to use as.numeric to make a column of data numeric. All right, so let's talk a little bit about some other things we might encounter. And we're not going to get too deep into these, but there are other two-dimensional data classes that we might use to store data. And we've talked a lot about data frames / tibbles, these kind of spreadsheet-like objects. But you may also encounter a matrix, which is composed of rows and columns. And the entire matrix has to be one class. It's kind of like a vector in that way. So all entries are either numeric or all entries are character. And so this can be helpful for, speeding things up if you've got just tons of numeric data, for example. So oftentimes used in things like genomics that are really data intensive. All right. And then another type of data class you may see, and it actually the most generic and most flexible is a list. And a list can hold basically anything. You could think of it like the grab bag, right? It can hold vectors, it can hold character type data, it can hold matrices, it can hold models, it can hold values, it can hold data frames, and it can hold other lists, right? It's a way to package up all kinds of objects into one single object. And so lists can be helpful when you need to do something repeatedly across lots of data. So maybe you need to wrangle several files at once. And I will say that they're a little bit more advanced, but you may encounter them when you work with others or look up solutions, or if you're a little bit further along in your R journey. And so you can make lists using the list function. And so here I've packaged together two vectors. One is a character vector and one is a numeric vector. And I've bundled them up into a list called my list. If I ask, well, what is the class of my list? It's going to tell me that it's a list, right? It doesn't matter what's in it. It's just a list no matter what. All right. So to summarize, we can coerce between classes using as.numeric or as.character. We can also do as.logical. There's a whole bunch of those. Data frames, tibbles, matrices, lists. These are all classes of objects that you may encounter. And lists can contain multiples of any other class of data, including lists. Calendar dates can be represented with the date class using some of these really handy LubraDate functions. So there's YMD, there's MDY, and there's just tons of variations on this. So if you type in LubraDate, this kind of box pops up. You can scroll through all of these. There's tons of them, right? So different formats you can have. Definitely a ton of functionality in case you're working a lot or want to work a lot with times and dates. So once you are able to, set up your date columns correctly, you can easily subtract date or POSIX CT class variables and then pull out aspects like year. So for example, if I wanted to make, I had this information here, but really I was only interested in the month or something like that, I can easily extract that and make it another column. All right. And as I mentioned with the last module, there's a little bit more advanced learning with some extra slides in this file. But for now, let's go ahead and get a little practice with the lab. Let's take a moment, get our file and everything going, and we'll run these first two chunks, the 1.1, to create some objects. Let me get rid of that, and I'll give us a moment to get to that point. So creating those objects, you should see all four of those in your environment, hopefully. All right, so hopefully we've got these all loaded up. And so let's explore the class of each of these objects. Let's do class of int vect. It's an integer. So these are whole numbers. And class varand vect, also an integer. Also, I could be extra sneaky and just determine what they are right here. I don't actually have to hit any code or do any code, but always good to practice. All right, so we've got a logical and we've got character. All right, so how do we feel about this? Are TF-vect and TF-vect two different classes? It does look like they are different, right? So why do we think they might be different? Put it right here, actually. Yeah, why are these two different classes? Yeah, I agree. I think the quotation marks, are making this one a character, right? So minor difference, but something that we maybe should pay attention to. All right. Okay. So let's create a table or tibble, fancy data frame, combining these vectors together to create something called vect data using the following code. All right. And so what do I get here? it basically just stuck the object name as the column name and then stuck those values in there. So looks a little something like that. All right, so we're going to do some coercion. We're going to coerce rand_vect to character using as.character. Save this vector as rand_char_vect. How is the output different? All right, so let's say we wanted to just take rand_char_vect as our new object. We'll do as.character on rand_vect. All right. So if we take a look over here, we've got the only difference really is that there's quotation marks, but it's now treating it as character type. And I could also think about, doing this with the data frame as well. So if I did mutate and called our new column the same thing, rand_char_vect, said, all right, as.character of the column rand_vect, I would again see something very similar, but here it is treated as a character. All right. Any thoughts or questions about the coercion? Yeah, so I think that if you've got just one data set, right, and you're looking at the columns, you've got a lot of columns. I think Glimpse can be really nice for this. So we had CES earlier. Let me see if over here, let me run this code again. So this could be a nice way to just quickly see what the classes are for all of the columns. So yeah, getting that out there. But if you have lots of objects in your environment, I'm trying to think how you would maybe iterate through those to give you the class quickly. Is that more what you were thinking? Yeah, sure. Yeah. So if you've got just a single data set, Glimpse can be really good for that. But if you've got more objects, like lots of distinct individual data objects, then it gets a little more complicated. But if you ever if you encounter that, let me know. We could talk about it. Anything else? All right. Well, let's do one final bit of practice here. So reading in the SARS-CoV-2 wastewater data, and it's using water from different treatment plants to test for the virus and estimate infections in a community. And so they would do a start date, an end date, and kind of try to tease apart the difference there. So let's load that up and just take a peek. It's got the jurisdiction, town name, population, but it's got these dates start and end, and then the percent change in RNA detected. So 0% change and a large percent changed. So increased, decreased, kind of all over the map here. All right. So let's clean this data up. Let's create a new column named date formatted based on the date end column. We'll use dy to parse month, date, year, and we'll reassign it. All right. So let's take the SARS wastewater data and we're going to use mutate. And what did we want to call it? We wanted to call it date formatted. All right. And then we want to take the date end column. And remember, it was month, day, year. So we'll use the MDY function on the date end column. All right. And so I don't actually I didn't save that or reassign it, but I can see that it made a column. I just can't look at it yet. So let's reassign so that I can see those changes take effect. If I scroll all the way over, looks good. If I wanted to just take a quick peek, I could do date end and date formatted to look at them side by side, just to kind of do a gut check for myself. Okay. And so why is it important that we have the date formatted? So let's just kind of explore here a little bit and take a look at the maximum and minimum. So we could do the max of date end and the max of date formatted. And so kind of looking at these side by side, it seems to think that the most recent date when it's formatted as a character is September 9th, right? However, it looks like the most recent sampling date was actually in May of 2024, right? Not 2023. So it can be important for, detecting chronologically what's the maximum and minimum. So in this case, formatting, I think, is pretty important. And you can even see this over here, sorting by clicking on the column and here. So yeah, so I think we have a little bit more accurate understanding when we have made it into the date class.